Hello, welcome to Data Cookie. Today, we will talk about the lesser explored moons of Mars, Phobos and Deimos. They are irregularly shaped in nature, and were discovered, in August of 1877, by Asaph Hall, a famed American astronomer, who achieved this remarkable feat, upon being encouraged, by his wife, Angeline Stickney Hall, who was an American academic, and mathematician. This discovery, was made at the United States Naval Observatory, USNO, which is, one of the oldest, scientific agencies in the United States, located along the latitude, 38 degrees, 55 minutes, 17 seconds north and longitude, 77 degrees, 4 minutes, 1 seconds west. Both of these, Martian moons, were named after, the Greek mythological twin gods. Phobos, is a personification of fear, meanwhile, Deimos, aptly refers to the feeling of dread. Both in the myth, were sons, of the Greek gods, Ares and Aphrodite. However, under the modern astronomical naming conventions, as per the International Astronomical Union, both Phobos and Deimos, have been given a systematic designation, which is Mars 1 and Mars 2 respectively. When compared on basis of their size, both these Martian moons, are dwarfed by our moon, which has a mean radius of 1,737 kilometers. Phobos, roughly has a diameter of 22 kilometers or 13.8 miles, while measurements, for Deimos, have been found to be, 12.6 kilometers or 7.8 miles. While, comparing orbits, Phobos orbits much closer to Mars, having a semi-major axis, of 9,377 kilometers or 5,827 miles, while Deimos, has a semi-major axis of 23,460 kilometers or 14,580 miles, placing it further from Mars. Whenever an object, similar to these Martian moons, are orbiting around a larger body, like the Martian planet, it usually leads to the creation of an elliptical path. If we consider an imaginary line or axis, connecting the furthest points of this elliptical path, it would form the major axis, while an imaginary axis, connecting the closest points of the same elliptical path will lead to the formation of the minor axis. The orbital period, a term referring to the time required to complete one orbit around the planet Mars, also varies in both cases, for Phobos and Deimos, which is 7.6 hours and 30.3 hours, respectively. Due to this closeness of Phobos to Mars, it moves much faster. As a result, it sets in the eastern Martian sky, twice. Meanwhile, Deimos takes approximately 5.4 days, in terms of its moon rise. What's much more interesting, is that, when Galileo Galilei discovered the rings of Saturn, in the year 1610, he noted down a hidden report about his observation, in the form of a secretive anagram, which was misinterpreted by Johannes Kepler. He had interpreted the secret anagram as the Furious Twins, or sons of Mars, accidentally making the correct assumption that Mars had two moons, well before the original discovery made by Asaph Hall, in 1877, approximately 2 centuries beforehand. This prediction, however, we can agree, was a coincidence, or was it? When compared to our full moon night sky, Phobos would look 1/3 in size, while Deimos would look like a bright star or planet for an observer on Mars, only slightly bigger than Venus, upon looking from Earth. As a matter of fact, there are no total solar eclipses on Mars, since both moons are too small to completely cover the Sun, but total lunar eclipses, at least in case of Phobos, happen almost every night. Both moons are tidally locked, which means that they are always presenting the same face towards Mars, just like our moon here on Earth. This phenomenon is also known as synchronous rotation, which is unique for our moon, where, being tidally locked, the time taken for the moon to rotate around its own axis and to complete one revolution around the Earth are same, leaving no chance to see the far side. It's theorized that, due to Phobos' speedy orbit and rotation, coupled, along with slow decreasing tidal forces, at some point in the future, on one of its approaches to Mars, upon reaching the Roche limit, would cause total disintegration, and perhaps, formation of a ring around Mars. Either that, or, it will meet its demise by crashing into Mars. Again, For our curious viewers, the Roche limit or Roche radius is the distance from a planet, within which a second cosmic object will disintegrate due to its parent planet's exceeding tidal forces. This usually leads to dispersion of materials and formation of rings or forced ejection, and coalescence of broken celestial mass in orbit. The Roche rigid limits for Mars and Phobos is determined to be 172%, while Mars and Deimos is determined to be 451%. Deimos, on the other hand, is at a permissible distance that allows its orbit to slowly increase in size, enabling Deimos to move further away from Mars, which a similar phenomenon, as observed, in the case of Earth's moon. Many older craters present on the Martian surface, with their positions located far from the Martian equator, have been suggested as a proof for the presence of early, smaller moons that suffered harsh fate of crashing down onto Mars, which is soon to be expected of Phobos, and as a result, the Martian crust, as a whole, has shifted a lot between these said events. The theories about the origin of the Martian moons is controversial. One theory, on basis of the Tholen classification, that is, a classification of celestial objects, based on broadband spectra, obtained through 8-color asteroid survey, ECAS, has suggested the moons being a C-group asteroid type, which are dark. More evidence regarding feature similarities of the Martian moons and asteroid remnant objects lying near Jupiter's outer asteroid belt has also been found. Hence, it raises the possibility of these moons to have been captured during the early stages of formation of our solar system. While another theory states the possibility of early Mars being surrounded by several smaller protoplanetary bodies, which, upon impact with Mars, caused ejection of materials into the Martian orbit, forming these twin moons. However, the more agreed upon hypothesis is that, during the early stages of our solar system, Mars suffered from a collision with an object 1/3 its size, leading to injection of materials into Martian orbit. This material accumulated and coalesced to produce 3 bodies, with the first 2 constituting the better-known Martian moons, Phobos and Deimos, with a third larger body, simulated to be about the size of Ceres, a known asteroid moon, having slammed back to the surface of Mars. Subsequent materials ejected, later through millions of years, again under action of gravity, are assumed to have fallen back on Mars. In terms of unmanned exploration of these Martian moons, plans have been on the table for a long time, with several successful flybys, but unfortunately, no successful landing. One success story is that of the Russian Phobos 2 probe, which was part of the Russian Phobos program. This mission was the first to successfully take 37 photographs, covering 80% of the Phobos moon surface, with last contact made on 27 March 1989. While several other plans, as the 2007 mission by the European Space Agency accompanied with European Aeronautic Defence and Space Company, Astrium, proposed a mission to Phobos in 2016, with a lander, but plans were never followed through. NASA later proposed a Phobos surveyor mission concept, which is due to be launched sometime after 2023, with several other ideas, similar to OSIRIS-REx-inspired OSIRIS-REx 2 concept mission, for a sample return from Phobos. Russia also has laid plans to repeat the Phobos grunt mission around 2024. However, only time will tell whether these missions will avoid meeting the same fate as previous missions to the Martian moons. If in the future, missions like these were to succeed, what secrets will these moons reveal to us? What other mysteries do these moons possess, which still lie unknown to us? Perhaps it will show both Earth and Mars in the light of new perspectives and fresh thinking. What do you think the future holds for these enigmatic Martian moons? Comment in the comment section below, and also, don't forget to like, share and subscribe for more content just like this in the future.